Okay, so yeah, so when we have these work problems, right, then if we're working together, kind of a little shortcut way that we can do this is a times b over a plus b. But if you're working alone or working against, there's some problems where it's like, you know, you're filling up a sink, but then the drain is open, right? And so that's kind of like working against each other, right? Then you're going to have to do a minus b on the bottom instead of a plus b, right? Okay, so let's look at, maybe if we're going to just take a look at some work problems like this so you can see what I mean. All right. Let me move this over here. We'll kind of look at a few of these. These bigger here. All right, so let's see. All right, so number 5 is a working alone problem, right? Where number 3 is a working together problem. So why don't you guys take a few minutes, and I want you to try to do number 3 and number 5, right? And see what we can do here on this. And notice that this is a decimal, and I think on here it says like round to the nearest hundredth for your answers. So instead of leaving them as fractions, since there are some decimals that they're using in here, go ahead and try those two. Okay, let's see what you can do with this. Okay, let's see. Okay, so let's look at this now. Right, so remember on this one, since we're trying to figure out how long it's going to take for one person to do it alone, right? So the top part of the fraction, when we're doing the, you know, the shortcut, is still going to be 12 times the 5.14. Let's see. Not sure if it'll let me write on here. Let's see if it will. All right, so if we're looking at this one, kind of put it, let me do that. Sometimes those PDFs will let me write on it, and sometimes they're kind of crazy. So, so let's look at this one, right? So like I said, so the key thing in there that you're looking for is that you're trying to figure out how long it's going to take one person to do this. And so that means that we're going to be using this one that's the working alone, right? And so we're going to take the 2 hours that we are given, so the 12 times the 5.14 on the top, and then on the bottom we're going to divide it by 12 minus 5.14, right? And so you can go ahead and put that in, and this is like 61.68, right? And then when we divide that by the 12 minus 5.14, we get 6.86. And then when we divide those two, we get about 8.99 hours, so almost 9 hours, right, for the one person to do it by themselves. And we're expecting that that one should be more, right, because the one that should be the smallest amount is the one where they're working together, right? That should be the one with the smallest amount there. Okay. All right, let's see. Were there some questions? That makes sense. Or what else can I clarify for you on there? Everybody see why we're going to be doing the subtraction on this one? What kind of the keywords that you're looking for there, right? So when it says, how long will it take them working together? You'll do the A plus B on the bottom, where when you're working alone, you'll do the A minus B. And, and I'm not against you doing it this way for sure, right? If this way you kind of, look at and you're like, this makes more sense to me, then totally do it this way, if that's making better sense to you. But I just like to show this shortcut way just because I think it can help you see what's really happening there and how we can get to that shortcut. Okay. Questions on that one? Is there anything else I can help you with? Understand those type? Shannon, what do you mean not having the fraction threw you off? Not sure what you mean.
Well, I'm just more used to setting it up like 1 over 12 plus 1 over x equals like the 1 over,
right.
something.
The one job. Okay, yeah.
Figure out the 5.14 in the fraction.
Yeah. So it is a little bit different, and like you said, you said if you're like, oh, I just feel more comfortable, doing it this other way because I've kind of done it that way, that is totally fine. But, I did want to show you this other way in case it, makes sense to you. Of course, I don't want you to be using shortcuts if they don't make sense to you and why they're working. But I tried to show you in the one that we did, like where that shortcut is coming from and why that's always going to work. So, all right. Well, hopefully, just doing this one way or another, is going to be helpful for you. Maybe before we go on, I just wanted to bring up, there were some people that were asking about the graphene on Geogebra. And so if you have been having some problems with that, I sent a video out just in a message today that I hope will help you because, yeah, there is something kind of weird going on with the Geogebra graphene. They did some updates in the last couple of weeks on it, and now it has some kind of glitchy things with it where it didn't have that before. But I found that just sometimes by re-putting those equations in or refreshing the page sometimes will help fix that. So watch that video if you are having problems with that, if you're getting like these, parallel lines or you're getting these vertical lines, that might help you there. Okay. And if you need more help with it, remember that the first go round, I guess, of the project is due tonight by midnight. And remember, if you don't get it all correct, then I'll ask you to redo it, right? And I want you to keep redoing it because I want to make sure you understand what it is that, where you're making mistakes and what you need to fix on it. And remember, this is going to be going on your ePortfolio, so we want everything on there to be correct. So I'm giving you the opportunity to keep redoing it to get the full points on it. So just want to make sure that that's clear on there. Okay. So, all right. So Angeline, you got that figured out. Yeah, I know. You're not alone. I know that I've had a few students reach out to me kind of frustrated with that graphene. So Well, at least you have somebody there to help you figure that out, right? You got to use what you have there. And, and if you have somebody that you're like, help me figure this out. I have to do that all the time with my husband with, certain things too. So, all right.
I have a question about the project.
Yeah.
So when I try to do a screenshot or whatever of it to put in the project, kind of all the little things on the side are still there, like the full screen and the zoom in and zoom out.
So there is a little, which, are you using a Mac or are you using a PC? Or
I have a Mac.
Okay. So when you're doing, what are you doing to do the screenshot? Because I don't want a whole, I don't want there's one thing that you can do where you can pick how big the screen is. Do you know what I mean?
Yeah.
And so
it's just like the little, I don't know what to call it, but it's like
the little crosshairs.
Yeah, like the home button and the zoom and the full screen thing and the little settings thing.
But do you see something? Do you see on my, I don't know if you can see it on yours right now. Probably not. There's something that looks like a little T, like it's a, little plus looking sign that you can use, and it you kind of drag and it makes the, the part where you want to screenshot. Are you doing that or no?
I can't see that on mine.
I know it is not showing, but I'm saying, what are you using to?
I have just like the Apple version of snippet tool.
Let's see. Let me just look really quick.
I don't know if this is correct or not because I don't have Mac in front of me, but it says to use Shift, Command, and 4, and if you press them all at the same time, it should bring up the crosshair so you can select portion of the screen.
Yes, that is what I was going to say.
Shift, Command, and what? Sorry?
Shift, Command, and 4.
Let me have a look.
So make sure you're doing that, and then there should be like a little plus sign that comes up, and then you'll just drag.
Yeah, so it still is including the little.
But you get to pick what you're going to be screenshotting.
Yes, but they're they're on the graph. So even when I zoom out or zoom in, they're still.
What are on the graph?
It's the little home button, the zoom in, zoom out, and the full screen. So in order to have that,
can you stay on after class for a few minutes?
Yeah.
And we can figure it out.
Just because if I zoom out to not get those in, then my values for the months are 100, 200, 300, 400.
Yeah. So we can fix that totally. So I think let's just do it at the end of class though, so we don't take class time, for that, but I want to help you with it. But then also a student saying there's an option to download instead of screenshot it. So if you want to try and download your graph and save it that way, you can do that also. So that's good to know. I didn't see that before, so I'm glad to know there's that option too. That's awesome. So, all right. Well, let's keep going with the new stuff that we're going to be talking about today, because there are a lot of word problems, and that tends to be something that a lot of students get a little bit, freaked out about sometimes, but I hope that you can see that, when you're working through word problems, it's really just, trying to figure out, okay, well, what do I know? How can I organize this information? And, and also make sure it's very clear, what is it that you're trying to find? Because oftentimes you see that students get a little bit lost, and by the time they have things set up, they're just kind of like, oh, wait a minute, I don't even remember what it is I'm trying to do or what it was asking me to do. And so I want to make sure that, you take those things into account, and also make sure that you are thinking about the answers and that they're making sense, right? Kind of like I was talking about at the beginning of class with those questions that were on the warm-up quiz. I mean, you know, two of the answers didn't make any sense. And so you should, you know, try and, you know, think about that too as you're going through these. So the other type of problems that show up on 5.5 have to do with motion. And so they're dealing with this distance equals rate times time. All right, so let me write this here. So we got this distance equals rate times time. All right, so this is a formula that we use a lot in math, and you'll use it in other science classes as well. But we got to remember this relationship that we have here, because sometimes we're going to be asked to find the distance. Sometimes we might be asked to find the rate or part of the rate. And sometimes we'll be asked to figure out what the time is. So we've got to understand what we need to do in order to figure that out, right? So let's look at one example that you'll see, you know, something like it on your homework. And so let's say that Jane can paddle her kayak 5 miles per hour in still water. And remember, that just means that it's not a river that we're on, right? It's like on a lake. It's, you know, if you're in still water, then there's no current that is there, okay? That's what we mean by the still water, right? So it takes her just as long to paddle 12 miles upstream. Did I not say anything about? Okay. As it takes her to travel 28 miles downstream. Okay, and we want to determine the speed. Right, so speed of the current. Okay. So usually on something like this, I like to set them up in charts, again, just to kind of organize the information. It's up to you if you think charts are, you know, going to be helpful for you or not. But we know that we're given information about what's happening when she goes downstream, and also what's happening when she goes upstream. Right? So let's go ahead and make this chart here so I know and make sure it's clear. What is it that I'm looking for? What am I trying to find? Find the speed of the current, right? Now remember, last time we talked about these distance equals rate times time problems, I told you that remember that rate is comprised of two things, right? It's the speed of the boat, right, plus or minus the speed of the current. So we kind of talked about how those two things together make up the rate. And so we've got to remember that when we're figuring this out too. So let me put up here my distance, rate, and my time. Right, and then I'm just going to go ahead and fill in what I know. Well, my distance downstream is 28 miles. My distance upstream is 12 miles. Right, I don't know the speed of the current. That's what I'm trying to find. Right, but I do know that the speed of the boat in still water is 5 miles per hour, right? That's how fast she is able to paddle. So I know that going downstream, remember that that is pushing your boat faster, right? Downstream, you're going faster than upstream. So we want to add that amount in. So we'd say 5 is the speed of our boat, right? Plus whatever the current is. I don't know how fast the current is. That's what I'm trying to find here, right? But I know that I'd have to take 5, add the current to it to know what my downstream rate is. And upstream is going to be 5 minus c because you're going against the current, right? When you're going upstream. So we're going to subtract off that current. And then the time, there's something here, you know, like it says it takes her just as long, whoops, that looks like I'm crossing it out, right? Takes her just as long, right? So it's saying that the time is the same, right? And so that's kind of inferred there. And so you've got to kind of look for that. If it's not giving you information about time, look to see, is it telling you that they're the same time or something like that? Because there could be something like that happening. And so then we're thinking, okay, well, great. They're taking the same time. How do I fill that in here, right? But we got to go back to our formula, our distance equals rate times time. If we solve this for time, so try and get t by itself, well, that means we'd have to divide by r, right? So, and t would be by itself. So we're really saying time is found by taking the distance and dividing it by the rate. And we know the distance and we know the rate, and so that's what we're going to do to write in for our time. So for our time here, our distance is 28 and our rate is 5 plus c. Right? And then again here, distance divided by rate, so 12 divided by 5 minus c. Okay. And now that I have those set up, now I need to look at this and say, okay, I need to set these equal to each other because it tells me that they happen in the same amount of time. Right? So I'm going to set equal because same time. All right, so that's going to give me 28 over 5 plus c equals 12 over 5 minus c. And then from here, remember what we talked about last time in order to solve something like this, right? We're trying to solve this for c. And so we need to multiply both sides by the LCD. And so when I do that, the LCD is going to be 5 plus c times 5 minus c, because I need to have both of my denominators accounted for in there, and multiply this side by it as well. Oops. All right, and then I can cross out, right, my 5 plus c on the top cancels out with my 5 plus c on the bottom. On the other side, 5 plus c on the top and bottom cancel out. So then I'm left with 28 times 5 minus c equals 12 times 5 plus c. Okay, so let me stop right there a second and take what questions you have up to that point, because usually from here you can figure it out, but what questions do you have as far as the setup of this type of problem goes? All right, if there are no questions, go ahead and take a couple of minutes and just finish solving this for C. Figure out what C is on this. Okay, when you solve this, you came up with 2, but 2 what? All right, well, we're talking about, what did we just find? The speed of the current, right? So we've got to go back and think about what this is. All right, so that means it's going to be in miles per hour, because we're dealing with miles and hours. All right, so, and then we want to think about, does that make sense for an answer, right? Well, yeah, if our current speed was more than our boat speed, right, then we should rethink that, right? Our boat speed was 5, and so we're, you know, our current speed needs to be less than that. Otherwise, if we were going upstream, we'd never be able to get upstream, right? We wouldn't be able to move if our current was more than our boat speed. So that makes sense. And, you know, I mean, and also if you come up with negative answers or something like that, then you should take a look at it and see maybe you mixed up where your signs needed to go, right? Remembering which one needs to be the plus C and which one needs to be the minus C. Okay. How are you feeling about those type? On a scale from 1 to 5. So 5 being, you got it, and 1 being, I'm really confused. All right, well, nobody's at a 5, it looks like. So is there any, what can I clarify there for you? I can't see your faces. I can't see what you're doing.
I get confused on the ones that are, like when somebody's driving a different distance, or they're going opposite distances, and then at what point are they going to be the same? Or I don't know exactly know the words of it. But
yeah, no, I know what you mean. We can definitely do one like that. But how are you feeling about these boat type problems, where you're trying to find the speed of the current? So are you feeling better about those than you are about, like, if you're two people going, you know, towards each other, and when are they going to meet? Or they're going away from each other, you know, and when are they going to, you know, end up like 100 miles from each other or something like that, right? And it is, Jordan's right, it is going to take practice on these for sure, right? And trying to break down what it is it's, you know, that it's telling you, and how to put some of that information. And I really like the tables to organize the information in, because I find that it helps me to see, okay, what do I know and what do I still need to figure out? Where if I'm just trying to write things down, I can sometimes confuse myself and put numbers, in the wrong place because I confuse whether, it's talking about distance, rate, or time. So, but yeah. Yeah. And I understand what you mean, Jordan. It's just like trying to create these equations. I know, there's a lot of students that feel exactly the same way, right? And I know you'll get it. It will take some practice, but I know you guys can do this. So let's take a look at maybe one of those type. I think David was talking about where, they're like either going away from each other or something like that. Maybe let's try one where they're going away from each other. Okay, so let's try this one. And really, I need to hear from you guys. Like I said, it's just hard for me if I'm like sitting here talking and I can't tell how you're doing. Like if you're like, Becky, I really don't understand where that number came from, or why did you put those equal to each other, or why are you adding those, or, I try and take you through my thought process as I'm doing it, but that doesn't always clarify everything. So please speak up, because somebody else has that same question that you are having, I am sure. Okay. All right. So let's see. We've got Dimitri. And Claire. From the same house, right? So maybe they're, together at a house, but then they're going home, right? And so this house isn't their house. They're at like a friend's house or something, right? Let's say, I guess I should say from the house at the same time. Because some of the questions will say that some leave like maybe 6 hours or something after the other one. So it's important to know if they leave at the same time or if they leave at different times, right? So this first one we'll do, they leave at the same time, okay? Traveling in opposite directions. Yeah. So we know that Dimitri travels 40 miles per hour, and Claire travels 60 miles an hour. How long until they are 144 miles apart? Okay, is this the type you were thinking, Jordan? Something like this?
Yes.
Okay. Oh, it wasn't Jordan. Sorry, it was David. Sorry, Jordan. All right, so I'm just going to draw a little picture maybe of what's going on here, because I think it's easier to try and visualize in your mind what's happening, right? And so if you're trying to do that, then draw a little picture. So here's the house that they were both at, right, at a friend's house, and they're each going different directions from there, right? So Dimitri is going this way, right? And then Claire is going the other way. And all we really know is that, we're trying to figure out when they're going to be, right, 144 miles apart. Right? So And then we know some information about how fast each of them are going, right? But just to try and visualize what's happening on this, right? That's what we're trying to figure out, is when they're going to be 145 or 44 miles away from each other. All right, so let's set up our little distance, rate, and time table again here. All right, and part of this table, we've got, we know stuff about Dimitri, and we know stuff about Claire. Okay. And so then let's start filling in what we know, right? So I'm just going back through, reading through the question again, right? But I am taking note, right? How long? So I know I'm trying to find time, right? Is what I want to look at here, right? So I'm looking for time. So I'm going to kind of write that down to help remind me how long. Right, so my answer that I'm looking for is time. So let's take a look at this though and see what we know, right? Well, the distance is a little bit shaky, right? We know that we're trying to figure out when they're 144 miles apart, but I can't put 144 miles on both of those distances because then that's really going to be 288, right? And I can't put like 100 miles on one and 44 on the other because I don't know exactly the distance that each of them are going. I just know that together, right, it's going to be 144 miles, right? So that's kind of what I'm thinking through when I'm thinking about the distance. So I'm going to pick, I'm going to just skip over the distance for right now. Well, what do I know about the rate? Well, I know that Dimitri, right, is going 40 miles an hour. Oops, let me do his in blue. Right, so I know his rate is 40, and I know that Claire's rate is 60. Okay. And then what do I know about the time? Well, I know that they left the house at the same time. And so that I know that my times are just going to be t. If it said something like Dimitri left 2 hours after Claire, right, then I'd have to put that in as t plus 2, right, saying that they left later, or one of them could have been t minus 2. We'll talk about one like that, but if they left at the same time, then both of them are going to just be t. Okay. Now, remember our whole equation, our distance equals rate times time. So I know when I multiply my rate by my time, I will get a distance, right? And remember, this distance is unknown to me. I don't know, I just know together it's 144. But I'm going to go ahead and multiply these two things together. So I've got 40t. Right, and I've got 60t, right, because I'm just multiplying my rate and my time together to figure out my distance, right? And notice that this is distance, but it depends on what time I'm looking at, right? Because remember, they're going different, different rates, right? Their speeds are different. But I do know something else that I'm going to write in here, and maybe I'll just put it down like this. I know something about the total, right? I know that there needs to be 144 miles total in my distance, right? And so when I'm looking at this, I'm thinking, okay, so my distance for Dimitri is going to be represented as 40t. Let me kind of do this. So Dimitri is 40t, and then Claire is 60t, so plus 60t, and then together they need to be 144, right? because I don't know exactly what the distances are going to be at given times, but I know they have to be 144 miles apart. Okay, so let me stop right there a second, because this is where I think a lot of questions start coming up. So let me help you understand. If you're not seeing where I'm getting numbers from or why I'm doing what I'm doing, please speak up. Okay, well, let's go ahead and solve this for time. Remember, looking back, right, what I was looking for was time, and notice that t is what I'm solving for. That is the time. So if I go ahead and add these together, 40t plus 60t is 100t equals 144, and then divide both by 100. Right, and let's just go ahead and, you know, maybe just put this as a decimal. Some of your questions will ask for decimals and some will ask for fractions, but again, I think it's just going to make more sense if we do that. So we'll round to the nearest hundredth, so that's going to be 1.44. All right, so it's kind of nice. We were dividing by 100. It just moved that decimal place. All right, 1.44 what?
Hours.
Hours. Okay, so, you know, it's like, you know, not quite 1.5 hours, right? So a little less than 1.5 hours, but we'll just leave it like that. Okay. All right, did that help clarify anything there, David, or?
Yes.
Okay. Hope so. You guys want to do one where it's like somebody, you know, like, I mean, it could be a boat, it could be, you know, like a car or something like that, but where one, you know, person leaves first and then the other one's trying to catch up to them. Should we try one like that too? Yes, no, maybe, or are there? Okay. So yeah, because this one's kind of similar to what we just did. And so I'll kind of give you a little bit, you know, it kind of builds on the one that we just did. But now this time, right, it's going to be, you know, somebody leaves a certain amount of time later or something like that. So, and some of the ones on your your homework, and I'm taking this one right off of the homework, you know, I mean, yours might be different numbers and stuff, but it's just funny to me because sometimes the answers are really, you know, crazy big. So like on this one, we'll talk about the answer when we get there, but it's just kind of funny. But you do want to still make sure that it makes sense, right, with what you're talking about. And sometimes that's kind of hard to tell. Okay, but it says this. So Bill left the party early, traveling 4 miles per hour. 12 hours later, that's a long time, 12 hours to be leaving a party, but okay, right? Tiana decided to head out, right, to leave and catch up with him. I'm sorry, I just find this one kind of humorous because, okay, she's leaving 12 hours later and thinking she's going to catch up with him. All right, it's going to take quite a while. But she was going faster, right? So she ran 8 miles per hour. All right, so these guys are on foot, right? All right, how long will she have to run to catch up with him? Oops. All right. All right, so she left 12 hours later, right? But she's going faster, right? So anyway, I feel like some of these questions, and I wanted to do one that was actually on there because sometimes they are just kind of weird in what they're doing, okay? But we're still, let's think about what's happening here, right? They are leaving the same, let's see, go ahead and draw this down. So they were here and they left the party, right? So Bill left. And then Tiana left. All right, but she left 12 hours later. I'm just going to write that here just to kind of keep in mind. All right, but at some point, do you see, I mean, we're trying to figure out when it's going to catch up with him. So at some point down here, their distance is going to be the same, right? So I'm trying to make that clear that this is kind of that where the distance is. So the distance is going to be the same at some point when Tiana catches up to Bill, right? Wherever that may be, right? All right, so let's set this up, and I want you to try and set this up. Let me give you just a minute because I want you to think about, sometimes it just takes a minute to think through, right, what we know. And look back at the last one to kind of help you think through it. And just try something. Okay. So what do I know about the distance, the rate, and the time? Okay, let me have you look at this with me and see if you kind of, I mean, I'm not done yet here, but did you get these things filled in, right? And maybe you wrote it a little bit different on the time part. Did somebody write this different than t plus 12 and then t? Or do you understand why we have one of these as the t plus 12? Right, so this, the way I have it set up here, right, is if t is Tiana's time, right, and the plus 12 is with the Bill, or her, sorry, was with her friend Bill, because he left 12 hours earlier than she did, right? So he had a 12-hour head start, right? So that's why we've got to put the t plus 12 there, right? Could we have put t for Bill and then t minus 12 for Tiana? What do you guys think? Would that be the same thing? So I said if we did t here, oops, let me just write it in a different color here. So if we had t for Bill, could we say t minus 12 for Tiana? Right? Those would end up being the same thing, right? And if you went through and solved it, that would be fine, because this is still saying that Tiana left 12 hours later than Bill did, right? So you can either say Bill had a 12-hour head start, or Tiana left 12 hours later, right? So anyway, I just want to make sure it's clear that some of you may have had it set up like that with the t minus 12 on Tiana, and that's perfectly fine, okay? But just thinking through that. And then remember, the distance is right? Rate times time. So just like we did on the one above, we multiplied the rate and the time together. So we just do a little kind of side work out here, right? So we're doing 4 times t plus 12. And so that's going to be 4t plus 48. All right, if I distribute those through, I'm just multiplying these guys together, right? Rate times time. And then do the same thing with Tiana's. 8 times t is just 8t. Okay. All right, but then on this one, all right, remember last time, on the last one, we're trying to, compare and contrast. We knew the distance, right? It gave us a distance and said they were going to be, so far apart from each other. Well, on this one, it doesn't tell us that, but we know they're going to end up at, going the same distance, right? It's just one leaves later than the other, right? So this whole idea of this same distance is what you've got to be able to, see on this. And that's why I think drawing a little picture over here, about this and seeing, okay, so if I want the distance to be the same, then that means I'm going to set the distances equal to each other, right? So instead of doing this plus this equals a number, right, because I don't know what that number is, I'm just setting them equal to each other. So I'd have 4t plus 48 equals 8t. All right, and then let's go ahead and solve it for t. So 48 equals 4t. And so t must equal 12. All right, and so 12, sorry, this is where I get some of these questions. All right, so t is 12 hours, but remember that was how long it was going to take Tiana, right? But it wants to know, right? So let's see, how long will she have to run, right? So that's this 12, right? So she'll have to run 12 hours, right, to catch up with him, right? But it's going to be 24 hours later for Bill, because if we put 12, in place of t here, 12 plus 12 is 24, right? So anyway, kind of a silly, I don't know, some of these numbers sometimes they're just crack me up a little bit, but that's how you go about doing those kind. Does that help? You kind of see how to set these up and figuring out, like asking yourself, okay, what do I know about the rate? What do I know about the time? I know that rate times time gives me the distance, so I'll multiply those together. And then I know that they're going to end up with, at, same distance, so I'm going to set the two equal to each other to solve. Anything more I can clarify there on that one? Okay, I want to talk a little bit, at least, about 5.6 also, but I know some of you, oh my goodness, I had no idea my mic was muted that whole time, guys. Nobody said anything. Oh dear. Okay, well, did you follow what I did there?
Yeah, I wasn't. I said Bill's time as t and Tiana's as t plus 12, and I got the same answer.
Except, you probably would have got, but it says, how long will she have to run? So then you'd get 12, but then you would be adding 12 to that. So really your answer would have been 24. Does that make sense? But
Yeah, I got that too, but I got for the... Anyway, never mind. I'm just confusing myself.
yeah, so, and I was trying to say this Yeah, and you could set Tiana's time as t minus 12, and I was saying that, but then I got rid of that stuff, so I didn't know if you guys picked up on that. I can't believe that was muted the whole time. I'm so sorry, guys. But it won't be muted on the recording. And so if you go back, you know, and look at this recording, remember all the recordings are just at the very bottom, you know, the modules. There's just a whole other module that's just for all of our videos and stuff like that. So if you're kind of getting stuck on these type of problems, maybe look back through that again and see. But yeah, you could have T for Bill and T minus 12 for Tiana, and that would work just the same. Okay, but you got to make sure that since it's asking, you know, how long it's going to take Tiana to run, we really want her, I mean, it makes most sense for her to be T, but it could be set up the other way too. All right, what I was saying when I was muted and you couldn't hear me, that I wanted to spend some time on 5.6 also and make sure that we're, you know, at least have a little bit of time on that to do a few of those type of problems. But let's take just a couple minute break. I'm sure you guys need a little bit of a brain break for maybe 3 minutes or so, and then we'll have about a half hour to look at stuff in 6.6. And if you still, I mean, I am more than happy to stay on longer than 4 o'clock. If you are really struggling with these story problems and you're like, I'd like some more help with them, please stay on and we can look at more questions off of the homework that will be helpful for you. Okay, let's take a little 3-minute break right now. A monomial means that it has one term, all right? And so there's one term on the bottom, and there's a trinomial on this one on the top, and that one has 3 terms. So we're taking a trinomial, dividing it by a monomial. And so when we're doing that, it's kind of like what we were doing when we were dividing out greatest common factor, right? And so it's, you know, so one thing that we can do on this is we're really saying that every single term is being divided by that. So I like to set it up and say, and put this negative 2c squared d squared underneath every single one. And basically that would be making this into three different fractions instead. Let's see, whoops. So it's really going to look like this now. So this divided by this divided by this, right? So I can take that one fraction that we had before and divide it into 3 different fractions. And now I can just kind of do some canceling out and stuff like I was doing before, because this first term that I'm looking at is all connected by multiplication, right? So that means I can do some dividing out. So let's do that. So I can see that negative 2 divides into 6 negative 3 times. My c squared divided by c squared, it just becomes a 1, right? Anything divided by itself is a 1, so that goes away. And then d squared will divide into d to the 3rd power d times. So we have d to the 1st power now. All right, so that first term says negative 3d, and there was nothing left in the denominator. All right, so I just simplified that one. All right, now let's do the same thing with the second terms, right? So negative 2 divides into negative 16, a positive 8 times, right? And then c squared divides into c to the 4th, and leaves c squared on the top. And d squared will divide into d to the 5th and leave d to the 3rd. So I end up with plus, because it was a positive 8, negative divided by negative is a positive, so plus 8 c squared d to the 3rd. Maybe I should have just written that like that so it's easier to see. All right, and then the last one, right, -2 divided by -2 just gives us a 1. C squared divided by C squared gives us a 1. D squared divided by D squared gives us a 1. So 1 times 1 times 1 is a positive 1. So I can't just leave it off, right? There's still a +1 there. And that's probably where I see a lot of mistakes happen on these type, is people just forget that you know, anything divided by itself is 1, and we've got to keep that 1 there. And so this would end up being my answer for that. Any questions on when we're dividing by a monomial? Okay, let's look at, and I want to get into more of ones where we're dividing by binomials, because on those type we have to do long division, and so that, you know, is important to kind of make sure you understand what it's asking you to do here. So on this one, if it tells you to divide, so 2x squared minus 7x minus 15, and we're going to divide that all by x minus 5. All right, so this time we have a trinomial divided by a binomial. So when we're dividing by a binomial, we end up having to do long division with this. And so before I set this up, you know, with the variables and stuff in the long division, I want to just take you through just a long division problem with just numbers, because you've got to know the steps. And I know a lot of people have forgotten how to do long division. It's been a long time, and you usually just use your calculator to do it. But you can't use your calculator on this because we've got these variables involved. And so let's just take and look at, what if I had something like 4 divided into 185, something like that, right? So to do the long division, we say, okay, 4 can't divide into 1, so we're going to take 4 into 18, right? So I'm thinking, what times 4 gives me something close to 18, and that would be 4, so I write it above here. And then 4 times 4 is 16, so I write it underneath here. And then the next step that I do here is I've got to subtract, okay? And when I subtract, I get 2, and then I bring down the next part, right? Bring down that 5. And then I start the process over again. How many times will 4 go into 25? Well, I know 6 times 4 is 24. And then I'm left with a remainder of 1. And then, you know, so sometimes you just have, you know, so this is the quotient, is what we call it. And then this is the remainder. But sometimes it wants it written in fraction form. So the answer would be 46 1/4. Right? So 46, and I'm putting that plus sign there just because, I mean, that's basically what this means when I say 46 1/4, right? But I'm getting that 4 from what I was dividing by, right? So my remainder went on top, and what I was dividing by went on the bottom, okay? And we're going to come back to that idea with these as well, because we've got to use this. Okay, so first thing you've got to look for, and I brought this up in the quiz questions, is you first got to make sure that your polynomials are in descending order. So my highest exponent is a 2, and then the next highest is a 1, and then the next highest really says x to the 0 power, right? But anyway, so you want to double check for those, right? That those are in descending order, which it is. And if it's not, get it in descending order. And then our, you know, the number or the polynomial that we're dividing by is also needing to be in descending order. But that one usually is written that way. Okay, but when we set this up in long division, right? What I'm dividing by, right, goes on the outside of the division sign. And then the stuff inside, right, is what I'm dividing into. So that first part, 2x squared minus 7x minus 15. So you first have to make sure you have this set up right. Right? So what you're dividing by goes on the outside, what you're dividing into goes inside. All right, and then we're going to take these same steps that we were talking about over here when we just did our division without it. But notice how it's really similar. So you're going to be asking yourself, what times x gives me x squared, or 2x squared? Right? So 2x, oops, I don't want to have that as a green, sorry. 2x times x gives me 2x squared. So I'll write that underneath there. Okay, but that's not all, because we didn't have just one thing to multiply by, right? We have a binomial, so we also have to take our 2x and multiply it by our negative 5 and put it under that negative 7x. So I'll do 2x times negative 5 is negative 10x. Okay? And so that's kind of what we did here, but we had more than one thing we had to multiply by. And so that's where it's kind of different looking than this. But our next step, when we had just numbers, is that we were going to subtract next. And that's the same step that we need to do here, but we have two numbers that we're subtracting, right? So we're really changing the signs. So we're making this a negative 2 to subtract that. I'm subtracting a negative 10, so that means I'm really adding it, right? So if you want to think of that step as, you know, where we are subtracting as change signs, that might be another way to look at it. Okay, and then go ahead and combine those together. We can see the 2x squared minus 2x squared. There's no x squareds left. But then the next part, negative 7x plus 10x gives me a positive 3x. All right, so we had what was left over when we subtracted. Now we've got to bring down the next term. So we'll bring down that minus 15. All right, and then we'll start the process over again. So we're asking ourselves, what? All right, so it's going to go here, what times x gives me 3x? Well, that's going to be a positive 3, so I'm going to put plus 3 here. All right, so 3 times x gives me 3x, and then I have to multiply it by the other part of my binomial. 3 times negative 15 gives me negative 15. And then again, at this point, I subtract, or think of it as changing the signs. I'm going to change both of those signs. And so I end up with 0 as my remainder on this. So that means that this divides in evenly, right? And so that means that these two things are factors. So I'm going to write something out here. So if I did x minus 5 times the answer I came up with, that 2x plus 3, and I multiplied those together, do you see that I would come up with this trinomial that I was dividing by? Because there's no remainder left here. And so I know these two things multiplied together give me that, because multiplication and division undo each other, right? But that only works when we get a 0 here for our remainder. Okay? Okay, what questions can I answer on that one? All right, let's take a look at one where we're missing some terms, because one of the other questions that I asked you about is, does it matter if there's missing terms, right? And it does when we're dividing. We've got to watch this closely. So this time I have x to the third minus 10x plus 24. Oh, actually, let me do a different one. Good ones here to go around. Just 1 second. All right, we'll just continue doing this one. And then we'll divide that all by x plus 4. All right, so we can see that it's in descending order, but we are missing the x squared term because it needs, to be x to the third, then x squared, and then x, right? But we're missing that x squared term. So when I write this down in the form that I need, my x plus 4 is still going to be on the outside, right? Just like it is here. But my first polynomial, right, is going to go inside, and that's going to be, I'm going to put x cubed, but then I need to take account that there's a missing x squared term there, right? So I'm going to put plus 0x squared, right, minus 10x, and then plus 24. Okay, and then we're going to just go ahead and do what we were doing before there, right? So what times x gives me x to the third? All right, so so x squared times x gives me x to the third. And then I need to take that x squared and also multiply it by my 4. So x squared times 4 is plus 4x squared. And see, it was important that I put this 0x squared here because I can only add and subtract like terms together. And so that's why I needed to have this placeholder here for it. And then I'm going to subtract or change signs, right, which will leave me with a negative 4x squared, because 0 minus 4x squared is negative 4x squared. Okay, now let's bring down the next term, so minus 10x, and then we'll start it over again. So what times x gives me negative 4x squared? Well, notice that that first term is negative, so that means my answer up here needs to be negative. So negative 4x, right? Negative 4x times x gives me negative 4x squared. And then also multiply it by the 4, so negative 4x times 4 is a negative 16x. Okay, now let's change signs and combine those together, right? Those first, the x squared terms, right, go away. That's what we were trying to make happen. And then we're left with that 6x, positive 6x when I combine those together. Okay, but I'm not done because I still have another term to bring down. So I need to put plus 24, and then we'll start it again. So what times x gives me 6x, right? And that'll be plus a positive 6. And then 6 times 4 gives me 24. And then I need to change my signs. And again, on this one, I end up with a 0 remainder. All right, so my answer would just be this, x squared minus 4x plus 6. Okay, but we had to put that 0 in to hold that place open. Okay. Questions there I can answer? check. All right, let's try another one here. Let's see what we can do with this one. All right, let me work through it. Make sure we have enough time to kind of finish this one up. So hopefully just kind of follow along with me and see if you got to the point where I'm at here. All right, so we're going to start off and say what times 5y gives me 10y cubed. So that's going to be 2y squared, right? Because 5 times 2 gives me the 10, and y squared times y gives me the y to the third. And then I need to make sure I remember now I've got to multiply it by the negative 2 also. So 2y squared times negative 2 is negative 4y squared. All right, then the next step is to change signs, which will leave us 10y to the second power. And then I need to bring down my next term, so my negative 9y. And then start it again. So what times 5y gives me 10y squared? Well, that's going to be a positive 2y, right? 5 times 2 gives me the 10, and the y times y is the y squared. And now also take that 2y and multiply it by the negative 2, which is going to give me a negative 4y. Now let's change signs again. When I combine those together, I end up with negative 5y, and then I need to bring down the 10. So negative 5y plus 10. Let's do it one more time. So what times 5y gives me negative 5y? Well, that will be a negative 1. So negative 1 times 5y is negative 5y. Negative 1 times negative 2 is a positive 2. Right, and then I need to change the signs. And so that means I'll end up with 8 for my remainder. Right, and so remember on your homework, there might be just boxes to put it in, like it says it wants the quotient. And so you'll put this part in for the quotient. And then if there's a remainder, to put this in for the remainder. And if it asks for a box for a remainder and there is no remainder, you need to make sure you put a 0 in for the remainder box. Don't just leave it blank, otherwise it will mark it wrong. Right? So put a 0 in there so it knows that you're knowing that it's a 0 remainder. But the other way that it might ask you to write it is in polynomial form, where we take our quotient and then we'll do plus the remainder divided by what we were dividing by before. So 8 over 5y minus 2. Right? So it might ask for it in this form also on your homework, where it says do the quotient plus the remainder over the divisor. Okay? All right, how are you feeling about this dividing polynomials? Is that making sense? All right. Good. It looks like most of you are kind of feeling like you got the hang of that a little bit. So, so those are pretty much going to be the type of questions that you have on the dividing ones. So I would just say, so right now,